Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to simplify nth root radical expressions. Let's start with a few vocabulary definitions. So the nth root of a real number a can be written as a radical expression. If b to the nth power is equal to a, then the nth root of a is equal to b. Now, in your radical expression, this number right here, this is called your index of the radical. The symbol here is called your radical. And the number under the radical, this number here, is called your radicand. If there is no index, then it will be assumed that n is equal to 2. Now, in previous courses, you've already learned to simplify radicals with an index of 2, and those are called square roots. So let's review how to simplify a square root before we get into simplifying other nth root radicals. So in example 1, it says simplify each of the following. And in problem A, we have the square root of 63. Now, I'm going to be relying on this chart of perfect squares, perfect cubes, perfect fourths, and perfect fifths. But if you're simplifying square roots, then you want to be looking at all the perfect squares, okay? So the first thing I notice is that 63 is not in the list of my perfect squares. So what I want to do is find the largest perfect square that will go into 63. And right away I notice that I have 9 is a factor of 63, because 9 times 7 would give you 63. So I'm going to use the square root of 9 to help me simplify square root of 63. So what we'll do is we'll just split this apart into 2 square roots, where the first one is a perfect square and the second one is not a perfect square. So the factors of 63, square root 9 times square root 7. Then I can simplify my perfect square. The square root of 9 is 3. And then we have square root 7, which is not a perfect square, so we leave it in the radical. So my final answer is 3 square root 7. Now, if you're unsure of yourself and you're not sure whether you have the correct answer, you can use your calculator, type in square root 63, get the decimal approximation, and then you can type in 3 square root 7, get the decimal approximation. Notice they're the same. So that's one way you can check your answer. All right. So our next one, we have square root 75. So I'm going to split this square root 75 into 2 square roots. I want my first square root to be a perfect square. So I'm going to look up here at my perfect squares, and I want you to notice that 25 is a factor of 75, because if we multiply 25 times 3, we get 75. So I'm going to use square root 25 to simplify square root 75. So square root 25 and square root 3, because 25 times 3 gives me 75. And then square root 25 is 5 square root 3. Now what I'd like you to do is pause the video and try problem C on your own. All right, let's see how you did. So I separated square root 128 into square root 64 times square root 2, and then I simplified that to 8 square root 2. Check your answer with mine. All right, now let's move on to cube roots. When we're working with cube roots, we want to look at our perfect cubes. So now we're going to be looking at this next set of numbers here. Perfect cubes, 8, 27, 64, 125, 216. Sometimes you have to go a little bit bigger, but those are our most common ones that we'll be using today. All right, so I'm starting off with cube root of negative 8. Now, I want you to notice that 8 is in our list of perfect cubes. So we could also do negative 2 to the third power, and that would give us negative 8, because negative 2 times negative 2 times negative 2 is negative 8. So the cube root of negative 8 would simplify to negative 2. And again, let me explain the reason. That's because negative 2 times negative 2 would be 4, and then 4 times negative 2 would be negative 8. All right, now the cube root of negative 54. If I go back to my list of perfect cubes, I want you to know that 54 is not in that list. So I need a perfect cube that will be a factor of 54. And I notice that 27 times 2 would give me 54. So I'm going to use the cube root of 27 to simplify cube root of negative 54. So I'm going to split this apart, and I'm going to have a cube root times a cube root, and I want that first cube root to be a perfect cube. So I'm going to use negative 27 times 2, because that will give me negative 54. Now the cube root of negative 27 is negative 3, and then we have cube root 2. All right, problem F. We have 4 times the cube root of 375. So in this problem, I'm going to bring the 4 down, and then I'm going to split 375 into 2 different cube roots. So I want to go to my list and find a factor of 375. And in the list, I notice that I have 125. And 125 is a factor of 175. So if I were to multiply cube root of 125 times the cube root of 3, I would get cube root of 375. So let's simplify this. The cube root of 125 is 5, and cube root 3. And then I want to multiply my coefficients together. 4 times 5 gives me 20 times the cube root of 3. Now we're going to use the same process that we've used for cube roots. We're going to now use for fourth roots. So in problem G, we have the fourth root of 48. So I want to look now at my fourths. Okay, so 48 is not in the list, but I do notice I have 16, and 16 is a factor of 48. So I'm going to break this down to 2 fourth roots, and I want the first one to be a perfect fourth root, so I'll use fourth root of 16. Now 16 times 3 gives me 48. Now we'll simplify this. The fourth root of 16 is 2 times the fourth root of 3. All right, problem H. Negative 6 times the fourth root of 512. So I have negative 6 times, and then I'll break this apart into 2 fourth roots. So I want to go to my list, and I need something that will go into 512. So I'm going to use 256. So 2, the fourth root of 256 times 2 would give me 512. So let's simplify this. It would be negative 6 times the fourth root of 256 was 4. And then we have fourth root of 2. Now we'll multiply our coefficients to get negative 24 fourth root 2. Now, for problem I, I'd like you to pause your video and try this problem on your own. However, I do want you to notice that this is a fifth root, so you need to look at your perfect fifths when you're simplifying it. That's the hint I'll give you. Pause the video and try this problem on your own. All right, let's see how you did. I broke it down to 3 times the fifth root of 32 times the fifth root of 2. Then I broke that down further by saying 3 times 2 times fifth root of 2. And then my final answer, 6 times the fifth root of 2. Now, the next thing I want to look at with you is how to simplify nth root radicals that contain variables. So in example 2, it says simplify each of the following and assume that all the variables are positive. Now, to do this, you're going to be looking at your exponent and your index. So in other words, if the exponent will divide evenly by the index, then you have a perfect fifth root. So 10 divided by 5 would give me x squared. And then on the y, 25 divided by 5 would give me y to the 5. So we had a perfect fifth root. All right. In problem B, our index is 4. So the fourth root of m to the 20th power times n to the 12th power, I would simply divide my exponents by the index. So 20 divided by 4 gives me m to the 5 power. 12 divided by 4 gives me n to the 3 power. All right, problem 3. We have the cube root of 40x to the 6 y to the 5. Now, in this problem, 40 is not a perfect cube. So we're going to do what we did on the front of the notes. We're going to break this down to 2 different cube root expressions. In the first expression, I want only perfect cubes. Only perfect cubes. So if I look back at my chart, at my perfect cubes, notice that 40 is not in that list, but the factor 8 will go into 40. So I'm going to use 8 as my first perfect cube. So 8 times 5 would give me 40. So that's your coefficient. Now, go to your first variable, x to the 6th power. X to the 6 is a perfect cube because it will divide. 6 will divide by 3. Now, y to the 5 power is not a perfect cube, but if you had 3 y's, y cubed, that is a perfect cube, but you would have 2 left over because 3 plus 2 is 5. Now, we'll break down that first cube root. So the cube root of 8 is 2. 6 divided by 3 is x squared. And 3 divided by 3 is y to the 1. And then cube root of 5y squared. All right, let's look at problem D. We have the cube root of 54, a to the 4, b to the 10. So I want to break this down into 2 cube root expressions. Let's start by breaking down the 54. So going back to my list of perfect cubes, I'm going to use 27 because that will go into 54. So I know this would have to be a 27, and 27 times 2 would give me 54. Now for my A's, I have 4 of them. So I'm going to put 3 A's here and 1 here. For the B's, I have 10 of them. So I'll put 9 B's here and 1 here because 9 plus 1 would give me 10. All right, now let's simplify that first cube root. So the cube root of 27 is 3. 3 divided by 3 would be a to the 1 power. 9 divided by 3 would be b to the 3 power. And then what we have left over is cube root of 2ab. All right, problem E. We have the fourth root of 32 times m to the 6 times n to the 2. So I'm going to break this down into 2 fourth roots. And in the first one, I only want to put perfect fourth roots. So let me go back to my list. And I notice that I'm going to use 16. So 16 times 2 gives me 32. For m to the 6, I would use m4, and I have 2 m's left over. And then n squared, I don't have enough to make a perfect fourth, so that's going to go here. Now I'll break down the fourth root of 16 is 2, and then the fourth root of m to the 4th is just m. And what we have left over is the fourth root of 2 m squared n squared. Now pause the video and try problem F on your own. All right, let's see how you did. All right, I broke this down into 2 fourth roots. I used 16 times 3 for 48, and then I used m4 times m for my m to the 5 power. For my n to the 10, I used n to the 8 and n to the 2. Then I broke down that first fourth root. The fourth root of 16 is 2. The fourth root of m to the 4 is m. The fourth root of n to the 8 power is n squared. And then, of course, the second fourth root does not break down at all. So my final answer is 2mn squared times the fourth root of 3mn squared. And that concludes today's lesson on simplifying nth root radicals.